Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 10 from the October-November 2021. This is from the Pure Mathematics Paper 1, Variant 1, from the 9709 syllabus of the International A-Level. And here we have, this is from Cambridge. We have here what's called an improper integral, where one of the limits is infinity. Okay, so in this case here, what we're going to do is we're going to integrate this as normal. Okay, then we have to do something a bit different when it comes to putting in the limit of infinity. So first of all, we want to get this ready for integration. So we have to write this with the whole of the algebraic expression on the numerator. So we have to express this as 3x minus 2 to the power of negative 3 over 2. So I haven't started integrating yet, so I still have my integral sign, the limits, and I'm going to write this as 3x minus 2 to the power of negative 3 over 2. That's going to be integrated with respect to x. This comes from the law of indices, that when you have something 1 over a to the power of n, you can express that as a to the power of negative n. You can write the power as negative, and it gives you the reciprocal of what it's being raised to that power. So now what we can do is we can integrate. It's ready to be integrated. Now we can notice here that outside the bracket is a constant. It's basically 1. It's 1 times 3x minus 2. So we have here a situation that looks something like this. You can say something like this, where you have a function inside another function, and multiplying that is the differential of the function inside, or something of the correct form of the differential of what's inside the function. So you have a function inside a function. You have something raised to the power of negative 3 over 2, and that itself is a function. Outside the function, if you differentiate 3x minus 2, you get 3, which is a constant. Outside, there is a constant, so it's of this type of form. So we can integrate by what's called reversing the chain rule. So when you reverse the chain rule, the way I like to do it is as follows. I'll write this as 3x minus 2. I will add 1 to the power, because this is something that integrates by adding to the power, and then divide by the new power. So minus 3 over 2, I have to add 1 to it. Now 1 is the same as 2 over 2, same denominator, so that gives you negative a half. So I have to divide by negative a half, but then further I have to also divide by the differential of what's inside the function. So I'm going to divide by 3. Okay, now I have my limits of 1 and infinity. So continuing from here, this is going to be minus 3 over 2. So if you have 1 over 3 over 2, that gives me 2/3, because you're dividing something. 1 divided by a fraction is equal to its reciprocal. Right? If you divide something by its fraction, you multiply it by its reciprocal. So it's like 1 times 2/3. You're going to have negative 2/3, and then you're going to have 3x to the power of minus 2, 3x minus 2 to the power of negative a half. I'll just do this step by step so it's a bit clearer. To the power of negative a half. Let me just write that a bit clearer. So that's 3x, sorry about that, 3x minus 2 to the power of negative a half. And I'm going to put the integral brackets here, because minus 2/3 is a constant. If it's multiplying, I can write it outside, and I've got my limits of infinity and 1. Now, what I can do to make life a bit simpler for myself here, is I can take this as minus 2/3, and here I can write this as 1 over 3x minus 2 square rooted, because we know that x to the power of minus a half is the same as 1 over x to the power of a half, which is 1 over the square root of x, just to get ready putting in the values. Okay, so now we've got to put 1 in here, and we've got to put infinity in here. So we have minus 2/3 times. Now, when I put infinity over here, you can't really put infinity into anything, but you have to kind of estimate what it becomes. Okay, so we've got to think about what the limit is as x tends to infinity, okay, of 1 over 3, the square root of 3x minus 2. And then you're going to have to put 1 into here. So it's minus 1 over the square root of 3 times 1 minus 2. And this will give us our answer. So now you get minus 2/3 times. Okay, so the limit of this, when I replace x by infinity, I end up with 3 times infinity minus 2. So that's like a really huge number. And the square root of a really huge number is still a really huge number. So I'll end up with something that's like 1 over 0. Okay, it's like 1 over infinity. 1 over a really big number. This is going to be 1 over a really huge number. So as the limit, as if you have 1 over basically infinity is going to equal 0. So I'll write this outside there so that it doesn't take up too much space. So basically, this is going to be 1 over infinity. It's going to be 1 over something really big. Okay, if you take infinity multiplied by 2, it's still big. If you take the square root of it, it's still a really huge number. So 1 over a really huge number will tend to become 0. So this will tend to become 0. So you have minus 2/3 times 0 minus, and you have 1 over the square root of 1, which is 1. Okay, so you end up with minus 2/3 times minus 1, which is 2/3. So there's the answer to question 10a, 2/3. Okay, now for part B, which is also to do with integration. And in this case, it says the diagram shows a curve y equals 1 over 3x minus 2 to the power of 3 over 2. The shaded region is bounded by the curve, the x-axis, and the lines x equals 1, x equals 2. The shaded region is rotated through 60 degrees about the x-axis. Find the volume of revolution. Okay, so we got to find the volume of revolution. Now that basically means you got to take this, and I've explained this in a few videos. I'm going to put a link up to one of the videos where we go through the reason why the formula that we're going to use is going to be used, and I'm going to put a link up to it somewhere over here at this time in the video. Okay, so about 7 minutes and 20 seconds into the video, you'll see a card coming up here which will take you to the video where I explain the reasoning behind the formula that we're going to use now. So when we want to find the volume of revolution, it's based upon the volume of a cylinder, and it gives you the equation we're going to use is pi times y squared dx. Y being, the point here on the curve, how high it is, and dx being a small thickness of the, along the y-axis. And when you do pi y squared dx, it's like you have a cylinder. The radius was the y, so pi r squared h. Pi r squared, and the h is the thickness of the cylinder, and that will give you the volume. And if we take the limits between 2 points, like here A and B, that will give us the volume of that between those 2 points. Okay, so that's basically what we're going to use here. So as I said, I'll go into proper detail in that in another video, which I've linked already at the top here. So now we want to find the volume of revolution. So we got to take this equation. So first I'll write this as y equals 3x minus 2 to the power of negative 3 over 2, as we did before. So we know the volume of revolution is given by pi, don't forget the pi, times y squared, which is going to be 3x minus 2 to the power of negative 3 over 2 squared dx between the limits of 1 and 2, between those limits. So now, before we can start integrating, let me just simplify that. So you have pi between the limits of 1 and 2. When you raise something to a power, you have to multiply the powers. So minus 3 over 2 times 2 cancel out. So you're left with 3x minus 2 to the power of negative 3. That has to be integrated with respect to x. So when you integrate now, don't forget the pi. You're going to have to add 1 to the power. So you have 3x minus 2 to the power of minus 2. Now remember, this is the same principle as before. We have something inside the function. When you differentiate, you get a constant. Outside is a constant. So it's of the form that we need to reverse the chain rule. So we add 1 to the power. You divide by the new power and also by the differential of what's inside the function. So we end up with that's equal to pi times, and you got here, this is going to be minus 6 So you're going to have basically, I'm going to take out that minus 6. I'll take it out here. So I have minus pi over 6. And here I'm going to have 1 over 3x minus 2 squared. So I've just rewritten it in a way that's easy for me to put the values in. Remember, we've got to put the limits of 1 and 2 in there. So now I can put those limits in, and I'll see if I can fit it in this space here. Really, I should go to the next page, but it's okay. We'll just put it in here. So that's going to be pi times, and we're going to put the limits of 2 and 1. Those were our limits, right? Yes. So I'm going to have minus pi over 6, times, and now I'll put 2 in here. So I'll have 1 over 3 times 2 is 6. 6 minus 2 is 4. That's 1 over 4 squared minus, put 1 in here. I'll have 3 minus 2, which is 1. That's going to be 1 over 1 squared. It's going to be 1 over 1, which is 1. So you end up with minus pi over 6 times, that's 1 over 16 minus 1. So you have minus pi over 6, and you have 1 over 16 minus 1, which is negative 15 over 16, because this is 1 over 16 minus 16 over 16. And then you have minus times minus, which is plus. Let's get rid of the common factor here of 3. That gives you 2 and 5. 3 goes into 6 2 times, into 5 into 15 5 times. So minus and minus is plus. You have 5 times pi over 2 times 16, which is 32. And that's cubic units, because we're talking about volume. So there's the answer. We don't really have to write the cubic units, that'd be extra. If you put 5 pi over 32, that's fine. So there's the answer to part B of this question. Part C of the question is more to do with differentiation rather than integration, so I'll save that in a separate playlist. But you'll find this question answered. You'll find part C included with the playlist for this paper, which will be linked in this area over here at the end of the video. You'll find questions dealing with integration in general from P1 of Cambridge in this playlist that's linked over here. Here will be a link to a playlist dealing with volumes of revolution from P1, and you can subscribe to my channel by clicking on this link. Thank you for watching. See you soon.